Welcome to The Explainer. Today, we're diving into one of the biggest challenges for AI, memory. But we're not talking about just remembering stuff. We're talking about a perfect, flawless, lossless memory. It's a whole new way of thinking about how an AI works, where it's not about what the AI can cram into its short-term memory, but how well it knows exactly where to find the original, untouched piece of information it needs right when it needs it. You know, the researchers behind this whole idea kick things off with this brilliant quote from Einstein, and honestly, it just hits the nail on the head. As AI agents get smarter and we ask them to do more, they're dealing with these insane amounts of information. And the real measure of intelligence, as Einstein put it, isn't about memorizing everything. It's about building a system that can pinpoint the exact detail it's looking for instantly.
Okay, so here's how we're going to break this down. First, we'll tackle the core problem, information overload. Then, we'll look at how things are done now, the old way, before introducing this new revolutionary idea. We'll pop the hood on this new system, see how it stacks up head-to-head, and then we'll talk about what this all means for the future of AI. Let's get into it.
So what's the big deal here? Well, as we give AI agents bigger and bigger jobs, like sifting through mountains of scientific research or managing huge software projects, they're just getting flooded with data. It's like trying to drink from a fire hose. And this causes all sorts of issues, like their context window. Think of it as their short-term memory just overflows and their performance starts to tank. So, to get around this, the go-to method today is something that works ahead of time. Now, a lot of you probably know the system by its more common name, Retrieval Augmented Generation, or just RAG. The whole idea is to get all the information prepped and summarized beforehand, so it's easier for the AI to find something relevant later on.
The best way to think about this old way, RAG, is to imagine a speed reader librarian. Before you even walk into the library, this librarian has already blitzed through every single book and scribbled down a short summary for each one on a little index card. So when you come in with a question, they just flip through their cards to find a quick answer. It's fast, it's clever, and that's why it's so popular. But it all hangs on those pre-written summaries.
And right there, that's the critical flaw. You see, the paper points out that summarizing is really just a form of compression. And just like when you compress a photo, you always lose some detail. Those index cards are handy for sure, but they've thrown out all the tiny, specific, granular details from the original books. For a simple question, that's probably fine. But for a complex one, the answer might be in a detail that the librarian just forgot to write down.
And this is where the revolution really kicks in. The researchers are proposing a totally different philosophy. It's called General Agentic Memory, or GAM. And instead of preparing everything ahead of time, GAM works on a just-in-time principle. It doesn't bother with summaries. It's built from the ground up to go find the perfect original piece of information on demand. This slide just lays it all out perfectly. On the left, you've got our librarian doing all the work in advance. It's fast, but like we said, it's lossy. Information gets lost. But on the right, you've got the new kid on the block, the research team. They find information on demand, which means they preserve everything. It might take a little more work, a bit more active research, but absolutely nothing is ever lost. So how does this research team actually pull this off? Well, let's meet the two key players in the system. GAM is basically built around a duo of AI agents, and each one has a very specific, very important job. Meet the memorizer and the researcher. Think of the memorizer as a super meticulous archivist. Its only job is to organize all the incoming information perfectly. The researcher, on the other hand, well, they're the detective. As soon as a question comes in, it's their job to launch a full investigation and track down the answer. So, let's follow the memorizer's process. When a new piece of information comes in, it does two things. First, it creates a simple little memo, kind of like a sticky note, that just says what the document is about. But then, and this is the most important part, it files the complete original document away perfectly in a giant digital library called the page store. And this right here, this is the magic. The page store is a perfect lossless library. See, unlike the old way that just chucks the original and keeps a summary, GAM keeps everything. The full, unsummarized original source is always there, always accessible. No information is ever lost. Okay, so now you ask a question, and the researcher gets to work. It doesn't just glance at the sticky notes. No, it creates an actual research plan. Then it uses a whole bunch of search tools, keyword, semantic search, the whole shebang, to pull the full original documents from that page store. And here's the really cool part. It actually reflects on what it found. If the answer isn't quite right, it doesn't give up. It goes back, digs deeper, and refines its search until it has exactly what it needs. Okay, so we've got this more complex, more dynamic research team. It sounds great on paper, but is it actually better? Does all this extra effort actually pay off? Well, the researchers put it to the test in a head-to-head showdown against our old librarian models. And they didn't just ask it simple stuff. They used what are called multi-hop questions. These are the really tricky ones, where the answer is scattered all over the place. You have to find a clue in one document, which then points you to another document, and maybe even a third, to finally piece together the full answer. It's the ultimate test of an AI's memory and its ability to reason. And just look at this chart. The results are, and I'm not exaggerating, absolutely mind-blowing. On one of these really complex multi-hop tasks, the previous methods, our speedy librarian, scored a flat 0%. Nothing. They failed completely because the crucial details had been lost in their summaries. General Agentic Memory, the research team, it scored over 90% accuracy. This isn't just a small improvement, it's a completely different league, a total game changer. And that wasn't a fluke either. The paper is just packed with data showing that across all kinds of different tests and benchmarks, GAM consistently and significantly blew all the existing approaches out of the water. It just proved, time and again, to be a more robust, more reliable, and way more powerful system for memory.
All right, so let's zoom out. What does all of this actually mean? Because this isn't just some cool technical trick. A better memory system like this unlocks a whole new level of what AI agents can actually do for us.
So here's the bottom line. A perfect memory lets an AI graduate from being a simple assistant to becoming a true partner in complex, real-world work. With the ability to never lose a single detail and to actively research topics on its own, these agents can become genuine collaborators. The paper points out a few areas where this could be huge. Just imagine an AI that can help a scientist by reading and perfectly recalling details from thousands of dense research papers. Or what about an agent that helps a programmer by keeping track of every single function and dependency in a massive, tangled codebase? This is the kind of future that a system like GAM makes possible. And that really leaves us with one final fascinating question to chew on. For so long, one of the big limits has been the AI's imperfect, lossy memory. But what happens when that limit disappears? If an AI can be trusted to find any piece of information perfectly every single time, what new, bigger, more audacious problems will we finally be able to ask it to solve?